But in the meantime, does anybody have any questions about anything? Any questions about homework or anything like that? Go ahead. Yeah. You good. I just replied to you. Yeah, you good. You good. Yeah. So any math questions y'all got? Everybody good with adding, subtracting, multiplying, dividing? All right. Same thing, adding, subtracting, multiplying, dividing. Yeah. Yeah. Uh, All of that. Inequalities and equations, everything. You guys can use your calculators. I recommend the TI 36X Pro, right? Yeah, that one. Yeah, if you that's if you want to buy it. That's not that bad. It's $20, you know. You can also use the 84 if you guys want, the TI 84. They got the TI 83 upstairs in the library if you want to borrow it. You're gonna have to get here a little bit early because they close at 5, the library. But they have calculators up there that you can borrow if you don't feel like buying it. In my opinion, y'all should buy a calculator. Like I still use my calculator to this day. I'd be up in the supermarket, like I know this is not a sale right here. They lying to me, you know? Yeah. All right. And you got your formula sheets you can use as well. The formula sheets, if you look at the announcements at the end of it, like those are the formula sheets. You guys can print them out if you want and like be using them right now to help you with your homework, or wait till the test, whatever, you know. So everybody good with the homework? No questions? So I told y'all the homework was easy. Yeah. I know it's a lot. I know it's a lot of questions, but yeah, yeah, yeah. hmm I taught all of them how to use it, so they know how to use it. Yeah. 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 Got you. To be honest with you, the most important thing that you need to know on that calculator is how to add, subtract, multiply, divide. So as long as you know how to type in a number plus another number or minus another, you good, you know? Something big that we could talk about with the calculator. So if you're looking at the number pad, right? Like the numbers like 0, 1, 2, 3, 4, 5, 6, all those numbers, right? There's a gray. Well, some of them are gray. Let's just assume that the numbers are gray, right? So there's a gray number on like the bottom right hand side. So like picture this, like how's it go? Like 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. I think there's a period and then there's like something that looks like this, right? Yeah. Not right. That's what I'm trying to say. So this sign right here, this is negative. Appreciate it. Yeah. So this sign right here, this is negative. So imagine if I said like -3, right? So what that is I have to press this button first, right? And then push the 3. And that's how I get -3 in the calculator, for example, right? I want to elaborate about this because on the right hand side, you have these other buttons, right? Division, multiplication, minus, plus. There's like a similar button, and then you have the enter, right? So this right here, this sign, this is minus. This is not negative, right? So I just want to like elaborate about that, right? So if we were gonna do, for example, -5 -3, right? So the first button that you would press is the negative button, which is this one, right? Then you would hit the 5, right? And then you would hit the minus and then the 3, right? But if you confuse it, like say you flip it, say you hit the minus first and then you hit the negative with the 3 over here, right? The calculator is going to give you back an error, all right? So just wanted to let y'all know the difference between them, right? So if you have a negative number, you want this button. If you have a minus situation, like what is 5 minus 3, this button is what you're gonna press. All right. Questions on that? All right. So we good, we good, we good. If we finish early today, maybe we can do something a little fun. It was fun in my opinion. Mhm. Huh? Uh, Appreciate it, man. Thank you. Yeah. All right, this is really, really hard. Somebody tell me how to do this. Go ahead. Mhm. Uh-huh. Very good. Okay. Mm-hmm. Very good. Questions on this? Anybody? No? Okay, that was the hard question, huh? Oh, I know I'm gonna get y'all with this question right here. Oh, this is a good one right here. Y'all probably seen it on your homework, so y'all know what to do, but I'm gonna still ask it. How I do this? This is easier than the last one. How I do this? Okay, so tell me what to write. Mm-hmm. 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 Very good. That's it. So just copy the same equation instead of x, write a. All right. Not too bad, right? Mm-hmm. That's it. Mm-hmm. Yeah. One more? I got you. I got you. This one's even easier than that one. Yeah. How I do this? Throwing it back now. Go ahead. Go ahead. Mhm. Good. Mhm. Got you. Very good. Good. And that's it. All we did there was we combined like terms, which is a fancy way of saying that we added the like terms. So 7x plus negative 4x, positive 3x, negative 1 plus 5, positive 4. Questions about this? Anyone? Yeah. So whenever you have two different signs, right, you subtract, but keep the sign of the larger number. So you see how the 7x is positive? So 7 minus 4, 3, and keep the positive. So positive 3, negative 4x. Or you could say 7x minus 4x, same thing. Yeah. Yeah, the point is that you're combining the like terms. They have an x next to them, so they get combined together, and then the numbers that are just by themselves, they get combined together. All right. Good stuff, good stuff, good stuff. All right, let's just start off with a definition. This is what we're doing today. Sometimes my English is a little bad, right? So I might have accidentally mentioned this, but y'all didn't realize I was talking about this. So now I'm going to elaborate on it. This is like earlier, like last week or whatever. So we're going to be talking about functions. So a function is a relation that assigns to each element in its domain exactly one element in the range, right? So basically, right, a function, I'm going to plug in some value of x is going to give me some value of y out, right? But every x has a unique y. That's it in a nutshell. Those of you doing computer science, yeah, I will elaborate on that a lot more later on. Nickelodeon. Okay, I'm sorry. So in algebra, right? More often than not, functions will be represented by an equation. It is easiest to see if the equation is a function when it is solved for y. If each value of x represents only one value of y, then the equation defines a function, right? That's key, right? So 1x can't have two different y answers. That's not a function, all right? Remember that for computer science people in here. I don't know who it is, but I'm talking to somebody over in this area over here. I don't know. All right. So here's a question. Determine whether each equation is a function. Assume x is an independent variable. All right. This is mad simple. All right. Let's say A. I have 2x plus y is equal to 7. Right? All you got to do, solve for y. Somebody tell me how to solve for y real quick. Go ahead. Yeah. Very good. Not dividing. Give me another operation. I want to separate the 2x from the y, right? What is it? Exactly, right? I'm going to subtract 2x from here, right? To get rid of it from the y. But what I do to one side of the equation, I have to do to the other side of the equation, right? So I'm going to subtract 2x from over here. So now I have what? Y is equal to negative 2x plus 7, right? Here's my question now, right? How many y's do I have in this answer? How many y's do you count? One, right? So yes, this is a function. Something like that, right? Let's try B. Go ahead. I'm sorry. Oh, sorry. The plus. The 7 was positive. And this was a positive 7. It's dividing versus subtracting. But yeah. No. I can't combine them because they're different terms, right? The 2 has an x next to it, and the 7 is a number by itself. So the most that I could do is write them next to each other. Yeah. Not bad, not bad. Good question. All right, let's look at B. I'm not gonna lie, I hate B, right? I'm over here trying to do some work and B just gives me the answer right off the bat. That's nonsense. All right, the question, is this a function? Yes or no? How many Y's do you have? One Y, right? If you have one Y, it's a function. So yes, this is a function. Something like that, right? All right, let's try out C, right? Let me copy it. So I have C is equal to X plus Y squared equals 3. Awesome, awesome, awesome. Right? So now I want to solve for Y. So somebody do that for me real quick. Mhm. No, just because you have one Y. That's simple. Yeah. Right. Right. So what would you say this is? Is this a function? You tell me. This one right here, C, is that a function? Yes or no? No. What's different about C compared to B, for example? It's about the letters. What's different about it? Right. That's why it's not a function. Right? Because of that square. It's okay if the X has a square, right? Y is not allowed to have, right? Yeah. So to prove it though, what you would do, you just solve for Y. So subtract X from over here, what you do to one side, you do to the other. So now you have Y squared is equal to negative X plus 3. What is this telling me? This is telling me that some value of X that I'm going to plug in is going to give me back two values of Y. That's not a function, right? One X has to go to one Y, right? That's what it's saying over here in this definition up here, right? It's a relation that assigns to each element in its domain exactly one element in the range, right? That's what a function is. And then in Math 30, you'll learn graphically what is a function and what is not a function. That'll be a fun topic too. Right? Oh, I forgot to write the answer. No? Okay. And that's about it. How you guys feel? Do you guys understand this? Do you want to try one or you feel like we can move on? Yep, that's it. So as long as you can solve for Y and you have one Y, it's a function. Okay. So if it's unclear, like at the bottom, that is not a function because you don't know the value, you cannot find the value for X. We can find the value for X, but it's not X that I care about, it's Y. We care about Y. Yeah, I have to have only one Y. I can't have multiple Ys. So this is because what's confusing is that we use different letters or different variables. So got you. We might confuse this when we see an A or a B. Right. Now we will associate it directly with the Y. Right. I mean, all right, let's take it up a notch theoretically, right? So what I'm trying to say is for a function, it can have one input can't give you multiple outputs, right? Like what we're guessing. Kind of, kind of. It ties in a little bit. Like, what I'm trying to say is if I plug in a value for X, X being the input, right? I can't get two answers out. I have to get one answer out, right? If I get two answers out, it's not a function. Yeah. So if the answer is the key. Right. Right. Yeah. If you have multiple answers, that's not a function. That's something else. Short, short answer, yes, in this class, but theoretically speaking, it can be A or B. All right. That's why I like kind of switched up and I started talking about input and output. Right. One input has to give you one output. If you have multiple outputs for one input, right, then that's not a function. Yeah. Good questions though. Another way you could do this, if say you were on the test or something and you just didn't remember this, right? But you know that for a function you can only get one answer out. You can plug in a number for x and see what happens, right? And then that's another way to prove that it's one answer or if it's multiple answers. All right. I think solving for y is the easiest, but if you want, you can just plug in numbers and see what happens. You get multiple answers, then you know that's not a function. You get a single answer, all right, we good. That's a function. Hmm? So we good? Yeah, you good. Good. Yeah. Huh? Another one? All right. All right, you guys try. Go ahead. Not subtract x2, add, right? Yeah. So you just want to get y by itself. Once y is by itself, right? If it's just one y by itself, you good. It's a function. If you see multiple y's, that's not a function. What?
In this example, we're using Y,
Yeah.
it can conceivably be X other off.
Nah, that it wouldn't be. It wouldn't be. How could I say this now? Let's just say for conversation reasons, right? Over the years, there's been a development of like a mathematical knowledge, language, right? So we understand X to be our input and Y to be our output, right? But like if you forget about those variables, right? And we're just talking theoretically speaking, yes, it's just a variable, you know? But like yeah, like really and truly, like we just understand X to be input and Y to be output. Yeah. But
I was just trying to get an understanding, it's not necessarily, it's just for this example that it's Y.
right.
It can
Yeah.
just be,
Right.
said,
Exactly. Another way to think about it too, let's say I was doing something in business, right? I'm not using X and Y. I'm using what it actually is. Like this is the gross domestic product, like minus the whatever else, etc. I'm not gonna call it actually just X and Y. Right. Yeah. Mhm. So all right, let's go over this. So number one, is that a function? Yes or no? Very good. Number two, is that a function? Yes or no? Oh, very good. Number three, is that a function? Yes or no? Very good. That's it. That's the whole section. Uh, all right. Oh, go ahead. Go ahead. So that's more specific. That's a type of function. Yeah, we're just identifying if it is a function at all. Just one y. Yeah, yeah, yeah. All right. This is a new idea. All right, I'm lying. It's not really a new idea, but the way it's presented is new too. All right. So this is called finding the value of a function. It is very convenient to name a function, and most often we name it with F, G, H, or capital F, capital G, or capital H. In any function, for each X value from the domain, we get a corresponding Y value in the range. For the function F, we write the range value Y as F of X. This is called function notation and is read as F of X or the value of F at X. In this case, the parentheses does not indicate multiplication. All right. So check this out. We're talking about something called function notation. For the function y equals f of x, f is the name of the function, x is the domain value, f of x is the range value, the y, corresponding to the value of x. So we read f of x as f of x or the value of f at x. Any questions on this? Anybody? All right. So here's what I'm trying to tell you. This is equal. If you see something f of x equals some equation, that's the same thing as me telling you y equals that equation. They're the same, right? And I'm telling you that when you see this notation f of x, right? I'm not multiplying f times x, right? This is just the name, right? And this is your domain value. Said a little differently, that's the number that I'm going to plug into the function. Go ahead. Even though it has parentheses. Yeah. So whatever's in the parentheses, that's what I'm going to plug into the function and get my answer out. All right. So let's take a look. Let me give you guys an example. All right. Now we call X the independent variable as it can be any value in the domain, and we call Y the dependent variable as it can be any value that depends on X. All right. Here's an example, real quick. All right. So right here, you see how it says f of x is equal to 4x minus 5. This is a function, right? Now, we want to evaluate this function when x is equal to 2. So how would I write that? I would say f of 2, right? 2 is the number that I'm going to plug into the function. So this becomes what? 4 times 2 minus 5, which you know is just 8 minus 5, which is 3. So f of 2 is equal to 3, all right? Whatever is in that parentheses, you're taking that, you're plugging it into the function, right? It's just a new notation for what we've been doing, for the past couple of days, right? Also, we say that X is independent because that's the number that's being plugged in. We call Y dependent because the answer that Y is going to give out depends on whatever you put into it, right? All right, let's do an example real quick. So we have this function, f of x is equal to 2x squared plus 3x minus 1. What do we want to do? We want to evaluate the function at each one of these answers, right? So, just a quick recap, right? So f of x is equal to 2x squared plus 3x minus 1. Let's do A. A says that we want to do what is f of 3. Literally everywhere you see the X, you're going to place a 3 in place. So this is going to be 2 times 3 squared plus 3 times 3 minus 1. All right, here's the hard part. Now we got to evaluate it, right? So this is going to be what? 2 and then 3 squared. What's 3 squared again? Forgot. 9, right? Very good, right? So that's 9 plus 3 times 3 minus 1. All right, what's 2 times 9 again? 18, right? Plus what's 3 times 3 again? So 9, right? Minus 1, right? So what's this? Like 27 minus 1, something like that. And then 26 is our answer. Questions on this? Anybody? All I'm doing is just plugging in that number. Go ahead. Mhm. Yeah, yeah, yeah. Mhm. Yeah. It does matter, actually. Yeah. So it matters with negative numbers, right? So let's say that I had -3 squared, right? This means -3 times -3. So that's +9. But let's say that I had -3 squared, right? This means -1 times 3 times 3. This is -9. That's the difference. No, that's the negative sign over here, right? Like a -1, yeah. We see in the first one, negative is carried with the three, right? Because of the parentheses, but in the second one, it's not. That's the difference. Yeah, if there's a minus on the outside of the parenthesis. Yeah, yeah. Yep. So that's that. Let's try two. And that's A, right? So B, they want to know what is f of negative 2. I think. Yeah, yeah, it is, right? So this is what? Tell me what to write. 2. Very good. Very good. Uh-huh. Very good. Very good. All right, help me solve this real quick. What do I do first?
Ratios.
Yeah. Okay, so tell me what to write.
Times two.
Okay, so 2 times 4. Very good. Plus 3 times. All right, it's okay. Minus 1. All right, what's next? Uh-huh. Mm-hmm.
And then, 3 times -2 is going to be -6.
Very good. And then minus 1. Oh, yeah, yeah, yeah. Oh, yeah. It's implied. All right, so what is 8 minus 6? No. Give me something better.
8 plus -7.
Yeah.
Uh,
Yeah, that's the final answer. I was trying to get to 2 minus 1 and then to 1. But okay, that's good. Yeah. Questions on this? Anybody? All right, this is where I'm gonna get y'all right now. Uh-huh. You ready for C? C wants F of A. What's the answer? Give you back the original question right there. What's F of A? Hmm? Sure. What is F of A? Very good. All right. 2A squared plus 3A minus 1. That's my answer. Everywhere I have X, I just replace it with A. That's it. Any questions on anything? Buddy? Good? Y'all want to try one? Or y'all feel good? No? You want to try? You want to try one? No? Uh-huh. Because A is just a variable. So that's why we just replace the X with A and that's it. No. Oh, I understand. So the 2A squared, right? That's a different term from 3A because of the square. So they can only be put next to each other. Yeah. So we good? We can move on? Nobody got no questions? Nobody want to try one? All right. One more? All right, let's do it. This one's a little bit harder because we got T's in it. One second, hold on. Give me one quick second. All right, sorry about that. Just have to check on something. Let's look at A. A is asking me for f of 3. Tell me what to do. Go ahead, you can tell me. Uh-huh. Very good. Good. Very good. Very good. Very good. All right, then we just evaluate it, right? This is going to be what? 3 times, very good, 9 minus 2 times 3 plus 1. Go ahead. So what's next? You did it wrong? Why? Oh no, not the 9 squared. Like the 9 is from the square. Yeah. So what's 3 times 9 then? 27. Very good. Minus what's 2 times 3 again? 6 plus 1. All right, so now 27 minus 6 is what? Very good. And then what's 21 plus 1? Very good. That's my answer. All right. Questions on this? Anybody? All right, let's try B. B is a little bit harder. I want to do f of negative 1. All right. Tell me what to write. Mhm. Very good. Very good. Very good. All right. Now let's evaluate it. All right. So tell me what to write. It's going to be 3 times mm-mm, negative 1 squared, which is what? What? Yeah, 1, right? Minus 2 times negative 1 plus 1. All right. 3 times 1 is what again? 3. And then what's negative 2 times negative 1? Positive 2 plus 1. All right. And then what is 1 plus 2 plus 3? 5. Okay, good. And that's it. Oh, 6, my fault. My fault. Questions, anybody? Good. I got you. I got you. When you see the parentheses like that, like -1 squared, it means -1 times -1. Should be positive. Yeah. No, you have to use the parentheses. The same way you see me writing it is the same way you type it in the calculator. Yeah. All right, this next one's a little bit harder. I want to do f of t. F of t. Tell me what to write. Uh-huh. 3t squared minus 2 times the t plus 1, right? Questions, anybody? For the next to the 2, yeah. But the one next to the 3, there's 2 t's. Yeah. It's- right. It's 2. It's t times t. Yeah. So if I was to like expand this, it would look like this. 3t minus 2t plus 1. So it's 2 t's. Yeah. Mhm. All right. Let's move on. Yeah. This is like most of your homework, probably all your homework is just this concept of taking it and just plugging it in. All right. It's not too bad. All right. So for the function g of x is equal to 3x minus 5, we want to evaluate the function. This is literally the same type of thing we just did. Tell me what to write for A real quick. A is asking you for g of h squared. Very good. That's it. Questions on that? Anybody? Whatever's in the parentheses is what you plug it in, is what you plug in, right? All right, this is a little bit harder, a little bit harder. What is g of x plus 2? A little bit harder. How we do this now? G of x plus 2. Uh-huh. And then minus 5. Very good. But I can't just stop there. I have to evaluate it, right? So tell me what to do next. Very good, right? Distribute. Very good. And that's it. That's my answer. Right? Combine like terms. You get it. Any questions on this? Just plug it in, distribute, combine like terms. Well,
In other scenarios, like, is it possible to be asked to evaluate like for g of x is 2 and then be given values of x to allow it within that? Or is it only ever asked, like, will only ever be asked to evaluate um the function based off of that specific input? So like,
that specific input.
okay,
Yeah.
so
So
is it possible to see after, like, evaluate for GMS two,
yeah.
evaluate for GMS two in or nine, like, considering that X is three. Like,
Yeah.
it's not more than one input, it's just the X plus two.
In this class, no, there's only one input, but in the future it could be. Yeah. There's like there's topics in calculus that I'm thinking of right now, where you have a function and then you do something to it, and then you plug it back into another function, and then do something to that, and then plug it into another function. So what you're saying is like a nested function, like that's a thing that does exist, yeah. Hmm? Very good question. Oh, go ahead, go ahead. I'm sorry. I just blocked it. Go ahead. Uh-huh. The equation is it's always the same equation from the top. We're always dealing with the same equation from the top. The g of x is equal to 3x minus 5. We're just plugging in the x plus 2 into it. And then we just evaluate it or simplify it, and that's it. All right. All right. So for those of you that don't take notes, right? Like do me a favor, like continue not to take notes. Don't write this next example down. I always put this on the test and everybody gets it wrong. Mhm. This is what is g of x plus g of 2? How I do this? G of x plus g of 2. Hmm? Yeah, that's it. Like tell me what to write. I'm trying to answer this. Yeah, I'm trying to answer that. Mm, not subtract. Tell me what to write after the equal sign. Go ahead.
Yes, fine.
Very good.
Yes, minus five, right? The minus two.
You can do it step by step. 3x minus 5 plus 6 is positive 1 minus 5. Wait, plus 1 minus 5. So this is 3x what? That's it. It's the best time ever. Ask your questions. And don't copy it because it's going to be the question on your test. Right? Where did the 3 come from? So that's from the original question up here. The 3x minus 5. Right. You just copy it. That's all you got to do. Mhm. And then you put the same addition sign there. And then you do the G of 2. And then you just combine like terms. That's it.
The answer is three X minus five.
3x minus 4. Because when you evaluate it, then you get all those numbers out. And you just add them together. Oh, go ahead.
The correct answer is C, other kill positives. Or that's what 5% stop. Start where the positive sign, positive threes. You know what I'm saying?
I guess. Are you talking about over here?
C.
For C, yeah. So the question for C is G of X plus G of 2. Yeah, and then all you do is just plug it in. G of X is 3x minus 5. G of 2 is 3 times 2 minus 5. Then you just evaluate it and combine like terms. That's it. It's simple, but everybody gets it wrong.
That's crazy.
Yeah,
That's why I was asking.
yeah.
Oh, wow.
Mhm.
You're just basically taking the X, substituting, and then the two.
Mm-hmm. And then you add them together. Yeah.
Oh, I know.
You guys understand the difference between question B and question C? They look the same, but they're not, right? In B, I'm plugging in the X plus 2 and then evaluating. In C, I have two separate functions that I'm adding together. Y'all see that? All right. Sometimes we might need the Knicks colors to help us out, right? Got our blue and our orange. Can't go wrong. And that's it. Go ahead.
But see that we're substituting X for X, that's like, so it's not, you're not squaring anything else.
Right. Well, in the original function, we didn't have a square, so that's why there's no squaring. Yeah. Yeah. Right. Hmm. Not too bad. Y'all understand, or y'all want to try another one? Another one? All right. This next one is hard. All right. This one got M's in it. Whoops. All right, try that out. By the way, like if anybody's interested, I'll be in tutoring on Thursday if y'all want to come. All right. I'll be there from 12. Not hard. All right, let's try it out. So I'm looking at A now. So A is asking for G of M squared. Tell me what to write. Uh-huh. M squared, very good. Perfect. Any questions on this? Good. All right, let's try B. Now B is asking you what is G of X minus 3? All right, so tell me what to write. And then minus 7, right? And what do I do after that? Close. I want to simplify this a little bit. Distribute what? Very good, right? Distribute the 4 into both terms. So this is 4x. What else? Good. And then minus 7, right? And what do I do after that? Or tell me what the answer is. Yeah, what is that? Good. So 4x minus 19. That's it. Any questions on that, anybody? It's just a name, the GX here. We good? All right, let's take it up a notch. All right, let's do C. C says what is G of X minus G of 3? Tell me what to write. Mm-hmm. Okay, so 4x what? Minus 7, very good. What else? Minus 4 times 3, okay, and then minus 7. Good. All right. What should I do next? Somebody tell me. Good. This is 4x minus 7 minus 4 times 3, 12 minus 7. All right, what's next? Good. That's a good question. All right. Why did I do that? What do you think? It has a what in front of it. Exactly. That's why. Right? Because this is g of x minus g of 3, right? The whole thing of g of 3. So in parentheses, this is g of 3. Yeah. All right. So what should I do next? What's my next step? Before that, before that, 12 minus 7, right? What's that? 5, right? So this becomes 4x minus 7 minus 5. Now let's combine like terms, right? So tell me what to write. Put on this. Negative 7 minus 5, which is what? Good. And that's it. Questions on this? Anybody? We good? All right. No. So you're copying the 4x minus 7 because that's g of x. G of x is 4x minus 7. All right. And then you're subtracting it from g of 3, right? So the same 4x minus 7, but you place the 3 in place of the x. And then you just evaluate it, combine like terms. So I got you. Mm-hmm. No. Yeah. What?
That, and
Yeah.
you see, it's almost a trick, we're just repeating it twice.
Right.
The first time is just plain,
Right.
because X is just making it by one,
Right.
and then the second one is by three.
Right. That's it. And then you combine them with whatever operations in between. That's it. All right. Let's do another question. All right. Word problems. Yay. Okay. So the number of unread emails in Sylvia's account is 75. This number grows by 10 unread emails a day. The function n of t is equal to 75 plus 10 times t represents the relation between the number of emails n and the time measured in days. All right. So question A, determine what is the independent and the dependent variable. All right. I'm asking you in other words, what is the x and what is the y? Tell me. What is the input and what is the output? What is the domain? And what is the range? That's what I'm asking about. Yeah. No. You tell me. Right. So I'm looking for the words out. I want to know what is the independent and dependent variable, or what is the x and what is the y? Which one is it? Say it again. 10 time. Okay, so you're saying time is dependent? Mm-mm, not that. The emails depend on the time. So so which one is X and which one is Y? Independent is what? Uh, Go ahead. Right, right. The independent is the days, and the dependent is the number of emails. Right? Go ahead. Ask your question. Yeah. No, I got you. Yeah, yeah.
That's fine.
I got you. All right. Another way to think about this, right? You saw that function that was there, n of t, which is the number of emails, is equal to 75 plus 10t, right? Dependent is whatever's in the parentheses. excuse me, independent, I'm sorry, is whatever's in the parentheses, right? And then whatever the name of the function is on the outside, that's the dependent. That's another way to think about it. Hmm. Yeah. Also in the function, the one that's like in the function itself, right? That's the independent. Right? That's another way to think about it. All right, cool. What's B? B says find n of 5. Go ahead. 125. How'd you do it though?
Um, 5 times.
Uh-huh.
Um, N, T plus 75 plus 10, put parentheses 5 until.
Very good. Which becomes 75 plus 50, which you said was what, 125? And that's it. All right. But it also says to explain it. So explain to me what just happened there. What does the 5 mean?
D.
All right. So she hasn't checked her emails in 5 days. So that means that she has how many emails to read in total? 125. All right. Emails. And then this is days. And that's it. Questions on this? All right. So we all know how to do word problems now. All right. So we ready for some marketing questions? All right, let's try another question and then we'll call it at that. Try this out.
Best.
Just watch the recording and then try it out.
Oh, starting in the basics.
Yeah.
But the last session was a little more understanding as you got to algebra.
Yes.
So that.
Yeah, yeah, yeah. I got you. I got you. Mm, exactly.
Okay.
So for part A, we want the independent variable, we want the dependent variable, and then we want to find n of 7 and then explain what n of 7 means. Right? Yeah, like another minute to try that. All right, let's try it. So I'm looking at A, all right? What is your independent variable? All right, I heard somebody say it. It was the days, right? What is your dependent variable? What is it? The number of emails, right? All right. Let's look at part B. What is n of 7? Tell me how to do that. Mhm. So 15 times 7 plus 100, right? So 100 plus 15 times 7. What's 15 times 7? 25? 105, okay. And then 100 plus 105 is 205, right? Okay. What does that mean? Explain it to me. Emails, right? In what? In 7 days, right? So Brian hasn't checked his email in 7 days. And now, today, 7 days later, he has 205 emails to check today. Right? Right? Like that's it, you know? Yeah, that's it. So it makes sense? Everybody? All right, so that's it for today. Oh yeah. Can I take this down? Is anybody still copying? Yeah. Oh, yeah, okay. You still copying? Oh, here you go. So I'm gonna stick around. Um, if you guys want to do your homework, go ahead. Yeah. The homework is pretty easy, so y'all probably finish that in like 5 minutes. If you guys finished your homework already, you could go, no problem. But y'all welcome to stick around and do it if y'all didn't finish it. Huh? Nice. Oh, cool. I love it. Thank you. Yeah. I was like, yeah,
That actually, I like it.
yeah.
He did the math.
Yeah.
You should take a picture of it.
I should, you're right. Take a picture.
You know,
Like,
share.
this looks crazy, but yeah, I just why not? Nice.
You should grab the
Yeah.
faculty.
Yeah. Absolutely. Yeah. You should. I see you, man. Tomorrow, yeah. Another day.
My week is mad.
Love your shirt, by the way. Spider.
Let me see your shirt.
He got a Dragon Ball.
Dragon Ball?
Shirt. Yeah.
Anime.
Dragon Ball.
Have you watched One Piece?
I haven't,
You
but I heard
should.
I heard good things about
You
it.
should watch
Yeah,
it.
heard good
To me,
things.
it's the best anime ever. It's not
Yeah.
just because it's a cartoon, it's everything that you learn.
Right.
You like watch it better.
Yeah,
Especially there's a lot of psychology and
it's good.
social critique
Yeah,
also.
that's good. Yeah.
Netflix has it. So,
I'm gonna check that out. Yeah.
like,
Thanks, you too. I'll see you. How's everything going with you, man? Good about you? Good. I'll see you, man. All right. Kelvin, you cool? I could take it down?
Yeah, you can take it down. I'm not saying it all this time.
Got you.
Our early vote.